This video will show you how to check your quality of variance assumption using the Keith method. In order to check the assumption, you need to run your linear regression. In this case, I have student success as my y and computed centered locus of control and centered self-efficacy as my x's. I'll request my residual plot with a z-resid on the y and a z-pred on the x and histogram of the residuals. Click OK. First red flag that the quality of variance might be a problem is that I have a megaphone pattern in my residuals. But according to the Keith book, the assumptions need to be extremely violated in order for us to worry. So how I will check that is I will divide up these residuals into 10 equal slices according to their predicted values, and I will check the slice that has the biggest variance, which is going to be the slice down here, with the slice that has the smallest variance, which is going to be the slice down here, and look at their variances. And if the variance of the largest slice is 10 times larger than the smallest slice, I might need to do a transformation. Otherwise, I can safely ignore it. So I will go to my regression again and go to the save command. And I will request that I get the unstandardized predicted values, get those things on the x-axis, and my residuals, which are on the y-axis. Click continue, click OK. I get two new columns. Here's from a previous run. I'll get rid of those right now. I get two new columns. I get the predicted values. So these are the predicted student success for this given student who has a negative 2.98 of their centered locus of control and a 1.18 on their centered self-efficacy. And the model is wrong by about 4 points for that particular person. Next, I need to divide up my residuals into 10 equal slices, or in this case, 2 equal slices, according to the predicted values. So I'll click on this thing here, the cut points for 10 equal groups. Click OK. You get some output. So from negative infinity to the first 10% of the data is the number 10.376. And from 21.766 to positive infinity is the top 10% of the data. That's all the information I need in this case. And so I will transform into different variables. Find my predicted values, and I'll call this new variable groups. Click on all the new values. So from negative infinity to this number right here, so it's going to be 13.77, is going to be group 1. From that value to positive infinity is going to be this number here, or this selection here is going to be 21.766, and that's going to be group 2. All other values are going to be group 3. I'm not going to care about those as much in this case. Click continue. Click OK. I have a new column where if the residuals are in that first 10%, they're in group 1. If they're in the middle 80%, they're in group 3. And if they're in the top 10%, if I can find one, they're in group 2. I will go to Data, Split File, Compare Groups by, well, the variable groups. Click OK. Then I will request the variance for those 3 groups of the residuals. So find the residuals, res underscore 2. Find variance. Click OK. Oh, and look, it's pretty close, but it's not as bad as you might think. The variance for the top group is 171. That's group 2. The variance for the bottom group is 33. 171 is not 10 times bigger than 33, so we can safely ignore the assumption violation in this case.